Chapter 9 in Algebra 2, we're looking at our test review for sections 1 through 3. Question 1 is going to ask whether you have direct or inverse variation or neither. And I'd like to make the following recommendations. First of all, for a problem like number 1, solve for y. Get y all by itself. Second of all, for direct variation, you're always going to have y equals k times x, a number times x, a number that could be a decimal, a fraction, even a negative number. For inverse variation, you'll have y equals k divided by x. The key aspect here is to see x in the denominator. We'll have a number divided by x. X is downstairs. Again, your number could be a decimal, fraction, could be a negative number. 1a is actually a little tricky. You can see some division. You might think it's inverse variation. That being said, if you have inverse variation, x is in the denominator. It cannot be that. What I want to point out is really there's a 1 up here, and we could rewrite this in the form y equals 1/3 times x. So really direct variation means you can rewrite your equation where y is some number times x. That is what we see here. For letter B, let's go ahead and solve for y. That means divide both sides by x, and you will have y is equal to 1/5 divided by x. X is in that denominator. It's okay to have a fraction in that top part of your division. 1/5 is also 0.2. You could have that as a decimal. For letter C, if you have y over 5 equals 2x, get y alone. Multiply both sides by 5. And 5 times 2x will get you 10x. This is what we'd call direct variation because we see a number multiplied to x. So this is going to be direct. For letter D, anytime you see an addition or a subtraction, the game's over for any type of variation. You can't have direct or inverse variation. Plain and simple, we have neither. For number 2, y varies inversely with x. That means y equals k divided by x. Simply plug in your x and y values, and then you can go ahead and cross multiply to find your k. 1 times k would get you k. 6 times a half. Well, you could simplify that very quickly. You can even multiply out 6 times 1/2. Don't even need the fraction bar. But you'll see it's 3. Where you're going with that, please make sure that you need to write an equation with x and y in it. So y is 3 all over x, and then we're done. For number 3, P varies directly as Q, so P equals K times Q. Now we're going to plug in our P value and our Q value, and we're going to solve for K. So we're going to divide both sides by 8, and you can simplify -4 over 8 to get -1/2. You could also have that as -0.5. But plain and simply, you'll have P is equal to -1/2 Q. For number 4, Z varies jointly with x and y, means Z equals K times x times y. And we can plug in 12 for our Z, 4 for our x, and 6 for y. 4 times 6 is actually 24. So we'll have 24k is equal to 12. When we divide both sides by 24, again, you can use a decimal or a fraction, but 12 over 24 would reduce to 1/2. You could use your calculator to see that if you'd like. Z is equal to 1/2 times x times y. Last one on this page. The force of a spring varies directly with its displacement. where X is in inches. So we'll write F is equal to K times X. Direct variation means we have multiplication. The displacement, which is X, is 4. And you can see the force that they're telling us about is 8. So 8 is equal to K times 4. Divide both sides by 4. You'll get K is equal to 2. Now from here, that means F is equal to 2 times X. And then you're done. For part B, you're going to use F is equal to 2 times X. You're going to have to use part A's equation. And they'll say if the spring is displaced 6 inches, find the force. The displacement is X in this problem. So we'll have 2 times 6. 2 times 6 is 12. The answer will be 12 pounds. And that is our first page.